Hey, this is Mr. Ariel. I'm here today with a lesson on states of matter. Be sure you've got some paper and something to write with, and let's get started. Now, I'm sure you already know there are four states of matter, and they're solid, liquid, gas, and plasma. Set yourself up a little table in your notes like this, pause the video to draw it in, and then we'll go through and fill in each part. Now, to fill in the first part, I want to take you over to a website called PhET. They make excellent free animations of science concepts. Now I've got this PhET set with some water inside a container that can be heated or cooled. Right now it's ice. You can see it's a really cold temperature right now. And you can see that these water molecules down here are all locked in place, but they are vibrating back and forth. Now if I cool the container some more, you should be able to notice that the particles slow down, but they're still vibrating. Now negative 273 degrees is actually the coldest temperature possible because that's when all particle motion comes to a stop. Now I've been holding this for a while. Looks like the PhET won't let me actually reach negative 273. Oh, there we go, we got it. And this temperature is actually called absolute zero because all particle motion has come to a stop. Now if I warm the particles some, you can tell that they start moving. So let me get it back to approximately the temperature of freezing water. And now you can tell those particles are moving around a lot more because they've changed into a liquid. They're not only vibrating faster, the particles are all sliding around past each other. Let me warm it up just a little bit more. And now you can definitely see them moving around just a bit more than when they were solid as ice. Now, if I start heating it gently, 100 degrees Celsius is where water boils. And pretty soon we should even be able to see a couple of molecules fly off of this liquid. See if I can heat it up a little bit more. There goes one. And that's basically evaporation. We're not boiling yet, but water is definitely evaporating from the surface of the liquid and starting to fly around the container. Now we're past 100 degrees, and so the amount of boiling has really increased in this chamber. Now I'm going to cut ahead, and now I've heated the chamber to a really high temperature, and all the particles are flying around the container at much higher speeds, and this is water in gas form. Basically, it's steam. Now going back to the notes, I filled in the particle motion row, but I left plasma blank. Sadly, my online demonstration doesn't simulate plasma, but it's basically superheated gas where the particles are moving so fast that they collide and strip off some of their electrons, and that leaves a bunch of charged particles behind. That's about all we're going to have to know about it for this class, so I'll go ahead and cancel out both of these boxes down here. Now the other way to define solids, liquids, and gases is whether they have a definite shape and a definite volume. Solids have a definite shape. They're not going to just change shape on their own, so I'll say yes for this box. Liquids and gases, though, they take the shape of their container, and so that's a no in both of those boxes. As for definite volume, solids meet that criteria, but so do liquids. You can pour a liquid into a different container and change its shape, but its volume will remain the same. Last up, gases, those don't have a definite volume. In other words, if you opened a sealed container of gas, it'll simply expand to fill the room it's in, eventually spreading to the outside and dissipating into the environment. Now that's it for this slide, so let's move on. Now the next thing we need in your notes is a bit about energy. Kinetic energy is the energy an object has due to its motion, and this could refer to an entire object like a baseball, where it's got a lot of kinetic energy as it flies through the air, but then it has zero kinetic energy when it's back resting on the ground. Now, kinetic energy can also refer to the energy of an individual particle of matter, like those water molecules back in the demonstration. Now, a different but related kind of energy is thermal energy, and that's the sum of all the kinetic energy of all the particles in a substance. Get that idea in your notes, and let's move on. Now, we need to explore the idea of thermal energy just a little more. Let's say I have two metal cubes, A and B, and one is 0.1 kilograms, and the other cube is the same type of metal, but it's 10 times larger. Now, temperature is defined as the average kinetic energy of the particles in a substance. I find students get really confused about this topic at first, so let's get some more notes on this. Let's say that each cube is the same exact temperature, about 110 degrees Fahrenheit. If you were to hold each cube in your hand, they would both feel equally warm. That's because they're the same temperature. Going deeper, every particle in cube A has the same kinetic energy as the particles in B. They'd all be moving and vibrating at the same speed. And that's again because they're the same temperature. Temperature is the average kinetic energy. But going back to thermal energy, that's the total kinetic energy, not the average, of the particles in a substance. So B is going to have 10 times more particles than A, so therefore B is going to have 10 times more thermal energy than A, even though they're the same temperature. If you're getting confused about that, but you realize that both cubes would feel equally warm to you, think about which cube would stay warm longer in your hand. Cube B is going to stay warm for much longer than A, and that's because B has 10 times more energy than A has. Get that idea into your notes, and let's move on. Next up, we need to think about those particles in solids, liquids, and gases, and how they were vibrating in place in solids, but moving around very, very quickly in gases. Set up a big area in your notes and make sure you've got some room above where you write solid, liquid, and gas, because we're going to come back and add information all up above and below those three terms. Now, adding thermal energy to particles in a substance by heating them, that just makes the particles move faster. Ultimately, you'll change a solid into a liquid, and then a gas, and possibly even a plasma. Whereas removing thermal energy results in the particles moving slower, eventually turning all of those phases back into a solid. Now, the exact temperature where a solid melts or a liquid solidifies is called the melting point and the boiling point. It's really important to realize that the melting point of a substance is exactly the same as its freezing point. Like ice melts at 0 degrees Celsius, but liquid water freezes at the same exact temperature. The temperature where liquids change rapidly to a gas is called the boiling point, and the reverse of that is called the condensation point. Again, those two temperatures are the exact same. The names simply tell you which direction the phase change is going. Now I'm going to change slides just a bit to clean up some things on the board, but you should be able to add the rest of the notes up here above what you've already got and below. I'm just going to fill in some things all around what I had here. Now I just cleaned up what I had written in the middle, but I'm not going to write any extra information in here. If you copied down that picture, don't worry, it's all going to work out. Now the last thing we need to get in our notes is about phase changes. And if you were to take a solid and cause it to change all the way into a liquid, that's called melting. And then if you change a liquid into a gas, that's called vaporizing. Now vaporizing happens in two ways. If it happens slowly at any temperature, that's called evaporation. But then if it happens rapidly at a very specific temperature, that's called boiling. Now, turning things around in the other direction, if we change from a gas back into a liquid, that's called condensing. And if we cool a liquid, we'll eventually freeze or solidify it and cause it to turn into a solid. Now, water freezes at a temperature that we find to be cold, but something like iron solidifies at well over 1,000 degrees Fahrenheit. Technically, red hot iron is frozen. Just don't get confused by the terminology. Last up, there are two special phase changes, and the first one involves changing from a solid directly into a gas without ever being a liquid, and that's called sublimation. Solid air fresheners work like this. They never turn into a liquid, but they slowly sublimate as they sit in a room, and their particles leave the solid form and enter into the air. Now, the last special phase change is called deposition, and that's what happens when a gas turns into a solid without ever passing through the liquid phase. Now, this video has gone on long enough, and your attention span may have already evaporated. I hope this video has been helpful to you today, and as always, thanks for watching.